All right, so now we'll share. All right, everyone. Welcome to the July meeting for ASEM. We got a pretty full agenda tonight, so we're going to get going on that. Okay. Why isn't my clicker works? There we go. All right, so off the bat, I'm going to keep reminding you of this. In September, we're going to have the first annual Dobson Fest at Jefferson College. So I'm hoping that we can get plenty of ASEM people out there for that. And we will be sponsoring this in 2023 at Bramwell Park. So I don't know the exact date, but it will be close to Dobson's birthday in September. So I don't know if we'll just make it a Friday night or we want to do something special. So we'll talk about that.
Kill two birds with one stone.
I'm sorry?
Kill two birds with one stone.
There you go.
Do you have to bring a Dobson?
You do not. But I mean, part of the thing is we want to be there. So if the public brings theirs, this is starting at 4 o'clock, not because the stars are going to be out to look at, but as people come in, we want to be able to help them with their telescope.
Okay.
Dobson, personally, we won't turn away any telescope like we never do, but it's supposed to be for Dobson. All right, Donna.
That's enough. Sure.
Okay.
My mind already.
All right. So we'll keep talking about this, but I plan on being there, and I hope that to see plenty of you guys there too. And I will bring my dog. The International Library Telescope Observing Week. I know I kind of talked about this at the end when I'm just talking about the library stuff, but I do want to put a little time in this. We're really trying to get the different libraries involved with this. I mean, they're doing the library telescope program, but we're trying to make it a little bit more. So we made an entire week where we can do things around it. This particular week, I have to look. I don't think we have an event for the library that week. I think it's the week before. I'm going to go back. Oh no, in September, we don't have any event. They didn't do one. We have one in mid-October. So I don't know if we want to do something like this or just pick a Friday night at Bramwell and say we're doing it. Yeah.
Since COVID, or post-COVID, or I don't know if we're even in post-COVID, whatever. But we used to do the camps at
Klondike.
For Fort Zumwalt to Camp Quiver River State Park.
Okay.
And I haven't heard anything. Have you heard anything? You heard anything?
They have not approached us.
I did get an email spam this past week from a friend, from a Fort Zumwalt teacher, and I wasn't sure if it was intended to be good or bad. But okay, that's all. Yeah. If they're not doing it, then we're wide open. But that's usually a pretty busy week.
I see what you're saying. Okay. I don't know what that noise is, or is that someone's phone? So, yeah, the more I think about this, I think of Friday night at Bramwell Park, and we just designate it, and we just kind of put it out there on our Facebook page and wherever else, and try to get the public involved. I sent this to our library here. I have not seen that they've done anything with it. The normal contact that we've had for years left the library, and so we've got new contacts, and I think they're kind of feeling their way around. So, but I'll keep pushing that. But this is great. This is our second year with the library week, so we're doing good. The group as a whole, we probably just should have a presentation about all the stuff we're doing sometime. Doing really good.
Is St. Louis County doing anything?
I don't know yet.
Okay.
Sort of like you guys, having all kinds of people changing over. It's like hard to keep track of.
Okay.
All right, so James Webb Telescope first target. So Dan, this is yours. Do you want to come up and talk about it? I'll give you my clicker, or you just tell me to move, or
It's gonna be all over the news next week. It's already.
it'd be good to come over here so
front and center.
they can hear you better. Feel free to sit there.
I just noticed this week that they put out that they're going to release the first images from the James Webb Telescope this coming week. And so I put together a presentation about it, partly because it fulfills this astronomical lead.
But he can only do it to people who are not ASEM members.
What? Oh, there you go, there you go.
So
Gotta read those details.
I got one, outreach has to be somebody who's not in the club.
So can we
It's
call
not
you,
outreach, it's somebody.
can we call you Token now?
Call you what?
Token.
Token, okay.
He's still gonna count.
The Astronomical League wants you to take a picture of a star, and it's actually the first star that the telescope pointed at to test the unfurling of the mirrors. And it's the star HD 84406. Also has a hint, it's like a, but it's right off of, pointing off of star of the Big Dipper.
Just real quick, are you guys on Zoom hearing okay?
Barely.
Barely? Okay. Dan will come a little closer.
Where is the mic?
Where's the mic?
Mike is right here.
Oh, gotcha. Okay. There you go. And this is that actual first image. You can see that it rotates, and I assume it has some kind of derotator that'll be used for images. If you want to go ahead and hit the button. And that's a star, not very spectacular, but it was the culmination of a lot of years of work. Next. The first images will be released Tuesday, July 12th, 9:30 our time. NASA has a website, and I'll include this. I'll post this after the meeting. Go ahead and hit the next. They have, they're broadcasting on a bunch of different networks, and that's everything they're going to do. So if anyone's up at 9:45 on Tuesday, or I'm sorry, 8:45 our time, these times are Eastern. That's what they're going to go through. Go ahead and hit the next. The targets, these were selected by a group of scientists. It seems like most of them are in the Southern Hemisphere. Not that it matters for the telescope, but go ahead and hit the next. First one's the Carina Nebula. Go ahead and hit next. And then Wasp 96b, they're going to do the spectrum of it. Wasp 96b is a large exoplanet. It's about half the size of Jupiter. And what's interesting about it is it shows very bright sodium, which they claim means it's somewhat cloudless. So they're hoping to figure out what it's made of through their spectrum. And then the next one is the Southern Ring Nebula, just like our Ring Nebula, only it looks brighter.
Not a ghost.
Go ahead and hit next. And then Stephan's Quintet, or 319. Most of these targets are pretty picture type stuff, because much like the Hubble imaged most of these things, but what 99% of the public sees are the pretty picture. Right. The other 99% of the science and technology that gets done because of those pretty pictures. It'll be interesting to see what the Stephan's Quintet looks like, because there's an iconic Hubble image, and I'm sure some of us, I've seen Stephan's Quintet at Danville with a 24-inch telescope, and it's not much to see. So it should be interesting. Go ahead and hit next. And last is a gravitational lensing galaxy. If you've ever heard of Einstein's cross, in other words, there's a galaxy out there and the light is bending around it to create multiple points that we should be able to see. So it should be interesting. I couldn't find much on what S-max means. It looks like something about the Abell galaxy clusters, but other than that, I really couldn't find a lot about it, other than Hubble pointed at it as well. But and again, there is an astronomical league certificate through NASA that you can earn. I don't believe you have to be a member. You have to provide some kind of outreach for the public. And I'll be using this presentation several more times for a lot more groups. And it's fairly easy to do. They just want you to point, whatever at that HD star and draw a picture of it and do an outreach event. And that's it.
Hey, Dan, is that SMAC 7023 or 07?
Back 2 slides.
I think it's 0.
0723.
Yeah, I could find the SMAC, but I didn't see the S anywhere, and unless that means Southern. But it had something to do with the Bell Galaxy clusters.
Yeah.
I think, well, you mentioned earlier the exoplanet. That's not on this list. Or was that on previous?
Yeah,
slide?
it's that Wasp.
Oh, that's the Wasp. Okay. The V tells you it's a planet.
Ready to go back?
So Dan, have you actually imaged any of that stuff?
Karina? I have images from remote telescopes. Karina is Southern Hemisphere only. The Nebula is Southern Hemisphere. I think it's in the Phoenix. The Wasp, or the gravitational lens stuff is nearly impossible for amateur instruments. That kind of thing is not, it doesn't take pretty picture processes to do. You need very good skies, high up, big mirrors, and short exposures. Obviously, I have imaged Stephan's quintet because I've imaged a large portion of the ARPs. Okay, that's really all I have. That's just my general stuff.
So yeah, SMAC 0723 is a huge galaxy cluster. I don't think it's.
I think it's named that way, but I'm not exactly sure what it is. I looked up a bunch of different papers and I couldn't really find much about it other than it's some kind of gravitational lens.
It looks like an acronym.
It is.
Or
That's, thank you very much.
Yeah, it's something about motion, the Bell Galaxy clusters or something like that.
Yeah, the problem is now that Hubble or now that Webb is kind of photographed it, it's like every hit is James Webb SPACs. And it's like, well, what about that? You're right.
Yeah.
So curious.
All right. Any more questions for Dan?
If anyone knows, the other thing I couldn't figure out was the field of view of the telescope. There's a lot of slides and a lot of things in the press kits about it, but I couldn't really tell. Some of them said it was double what the Hubble was, but there's a bunch of different instruments and the numbers, they would say it was double this, but then when you looked at the numbers were real small. Like the main imager said it was like 3 arc minutes by 3 arc minutes or something like that, double, because it has 2 detectors. I couldn't really tell what it was. So it's somewhat going to be interesting once they actually publish the pictures where you can actually
Compare.
place all of them and figure out what it was, because they showed an image of M51 and they showed what the Webb would look like, and it was much smaller, even though it said it was twice as large.
They issued a test image or something like that?
Just on the start, wasn't it?
Yeah, they did.
Would that, can you place on that?
I didn't think about that. I'm not sure it had a bunch of stars in it.
Yeah, I was gonna say probably not enough to really place on from.
All right. Anything else for Dan?
Dan, what is the goal? I know it's a solid gold shield. I know it's a thin. What's the deep goal?
I think reflective infrared.
Yeah, it's like a very thin layer of gold for it reflects, is what I thought it was.
so the original telescopes used silver, and today we use mostly aluminum. I think they use gold here because of infrared, isn't that correct?
I think.
Steve's shaking his head yes.
You got a 300-degree temperature difference between better transmission.
Yeah, I was thinking it had something to do with how they could cool it better for the infrared stuff.
All right. Thanks, Dan.
Thanks, Dan.
So just a quick update on Inventor's Forge. Don Lagwood and I, mainly Don, have been reaching out to the Inventor's Forge people, trying to figure out, hey, if we buy memberships, what can we do? Type deal. We are not getting a lot of return calls or, just return. So at this point, I think we're not going to pursue that anymore and just go ahead and get single memberships as we need it. So right now, Jim Rowe is doing the telescope building. So we're paying for those. And we'll do that as long as Jim's doing the telescope. And if there's other things that we as a club say, hey, this would be good to do out there because they got the facilities to do things, then, we can do that also. But yeah, this can't get a lot of response from these folks. So I'm not sure what that means.
They were actually at the show.
Was that?
They were at the air.
They were
show,
at the air show?
right next to the show.
Did you get to talk to them any or?
We just talked to them about some of the stuff they had. They were doing this 3D printing.
Yeah, they have 4 or 5 3D printers, if I remember right from the tour, so.
That's how you get to talk to them. Wait till the air show next year.
There we go.
Actually,
A whole year.
every other, actually. Every-
All right. Mr. Steve, this is you. You get to come over here in the captain's chair.
Oh, while I moved over here, I should say my daughter-in-law, Brian, graduate that she is in engineering, aerospace, whatever engineering from Purdue, worked on the James Webb for a couple of years before they ended up on the Earth. Is this okay right here?
Yeah, should be just fine.
Okay,
Do you want the clicker or you want me to do it?
you click it. I got a URL down here, tiny URL. And we'll talk about logging a little bit here that goes along with a couple of things. Hit the first slide. When you think about logging, there really are 2 different reasons to log. Okay, one of them is personal. And I copied that thing, that big long thing right there from an Astronomical League page. But the truth is, if you're logging for yourself, it's cool to do for a couple of different reasons. And I will tell you my most important reason. I am now 73. My memory is not what it was when I was 43. And so I will do something and I will forget why it didn't work. And so I will say to myself, now, why doesn't that thing work? And so I have to go back a lot of times and seriously reinvent the wheel, and I would truthfully say, one good reason to log is if you're trying to if you're trying to solve problems, get new equipment, if you're not sure it's going to work, write down what your problems are, because in the light of day, sometimes you need that kind of what you wrote down at night in the dark at 1 o'clock in the morning to get you through. Another reason is it's fun to go back over the years and see what you did and see how you've grown and see what kind of targets you've done. It's fun to go back and say, oh yeah, I remember the night that I was at someplace, Mark Twain State Park, and what I saw and what I did. I remember it as an outstanding night, but if I don't write things down, I won't know. Sometimes it's fun to go out some places and say, we were at Danville, and who was at Danville that night? And when the deer hunters came through at 2:30 in the morning, all those kinds of things. So ultimately, it's fun to log just so you can go back and look at the records. And the truth is, I didn't understand it when I first started observing with ASEM. It's like Jim Rowe had the log book out in the observatory. And he would always, at the end of the night, write down what he would do. And he said to everybody, write down what you did. I did sometimes, but most of the times I didn't. I think if Chuck still got that log book, if you look back on it, there's some fun things that went on in there.
Chuck does not have the logbook. If it's not in the observatory, I don't know where it's at.
Okay, so we're up that way. And so you can read that paragraph right there. And then the truth, why keep a log? Because if you're going to do an Astronomical League observing program, you got to, because that's what you turn in. And truthfully, when you turn it in, you're going to turn it in either to the national coordinator or you're going to turn it into me. And I got that on, I think, the next slide. What you have to do is you got to write down some kind of information. Now, the Astronomical League is going to ask you, in some cases, what the information is. They're going to ask you, what's the date, what's the time, where were you doing, latitude, longitude, transparency, seeing, those kind of things. But then a lot of it is kind of like wide open to you about what you want to write. And the truth is, a lot of times, if you're beginning, and I'll smile over to Andy, it's like, you don't know what you need to put down. I don't know how else to describe it. It's like, what should I put down on that piece of paper? Oh, 4 skunks walked by. That's not a cool thing. But oh, you can point the camera. Okay. Ultimately, the Astronomical League has got these things down. And again, they come from a web page that's on the Astronomical League website that probably the vast majority of the 20,000 members of the Astronomical League never look at. So that's why I tried to do it. The reason for the description is that it helps the observer become more detail oriented. It helps you look and it helps you see more. It helps you see deeper. I think the easiest way to describe it is the Astronomical League doesn't want their observing programs to be Messier marathon kind of thing. So the Messier marathon, there are 110 of them. You got the night to do it. Saw it, done it, check mark. Next one. And they want you to spend a little time on each object. No, you don't have to study each and everything for 20 minutes. But it's literally you look at it and you try to describe what you see. And I've got some things about this a little later on here. Go ahead, give me a click. As you log, keep in mind, okay, this is really important. I don't know how to say it. How are you going to submit your information to the guy who's going to look at the stuff? Okay. It may be that it's me and you can hand me it in any kind of form that you want because I got it and I can look at it and I can give it back to you. But if the guy is a girl or person, I'll pick person, I'll pick, if the lady lives in Honolulu, because the sketching person lives in Honolulu, you got to know about what you've got to do to get it into her hands. Okay. And if you are doing your logs in a particular direction, and all of a sudden at the last minute say, oh my goodness, how are we going to do that? It's going to be a lot of work on somebody's part. You got to ask yourself, are you going to send it in paper, United States Postal Service? The stuff won't come back. So don't send your originals, okay? Are you going to do it electronically? And if you're going to do it electronically, does that mean you're going to do this as a PDF, probably typed in Word or some kind of, thing like that and convert it to a PDF? Are you going to do it as a PowerPoint kind of thing? Some people do that. Are you going to do it as a web page? That's how I normally do mine. Okay. If you want to do it as something that's going to be emailed, realize that email does have a size limitation. I'm going to smile at Dan. 6-7 meg, it's going to blow up. So if your document's got lots of pictures or lots of drawings or stuff like that, it may look fine going out, but the person's web server out there or email server out there, SMTP server is not going to like it. It might, kind of reject it. So you might have to resort like looking and putting stuff in some kind of shared directory, Google Drive or something like that. And if you do that, you send them the URL. How do you choose to do it? Think about making a process as easy as you possibly can for the poor soul that has to look at it. I am one of those souls. Dan is one of those souls. And I will tell you that sometimes when you get stuff from people, it's like I have seen, and this is more to Dan than me, but if you got to turn in 100 images, here's a shared directory that's got 100 images. And then somewhere else, there's a document that describes all those things that are in it, but nothing's in order and there's no naming and everything's numbered wrong. And so you look at this first picture, you say, where is it? You look at the first description. Is there a picture? Try to make it as easy as you can on that poor person on the other end. They're a volunteer. They're a human being. They're a nice
They're
person.
gonna take forever because, I got to key those all up, figure out what you're doing here.
Okay.
They were
So
a nice person.
make it as easy as you possibly can for them, because I will tell you, the easier you make it for them, the better chance they will have of doing it quickly and getting it back to you. We have some ASEM horror stories about how long did that one take?
Commercial 400.
No, I was thinking of yours. Didn't you have one binary star or something, double star? Somebody had a double star program that was like 8 or 9 months or something.
No, it was, I think it's Outreach. It was the guy that's something.
Speaking of outreach, no, I haven't heard anything back.
I didn't think so.
Okay, anyway, the truth is you will submit that to one of two persons. You will submit that either to the Astronomical League's national coordinator, or you will do it to, right now, me. And the truth is the webpage will tell you which. If you don't like me, you can send it to the national coordinator. There's no reason you have to send it to me, okay? But it's a lot usually easier, because I think you'll find out that I'm faster. You'll also find out I was like, oh yeah, that's really good. Maybe you could add a little.
He double checks everything. That's what I like.
Yeah, I double check. That's probably, that's I see it's what it is. And then don't send your original logs to the national coordinator. They won't very short. I have the nicest collection of thumb drives, cheap thumb drives. I can't describe to you how nice my collection of thumb drives are for people who have sent me some. And when do you log? And the truth is, you know, you can log in the field. In some cases, you can log in the morning. Depending on how you log in the field, you might have to come back in the morning or sometime later and put stuff down. And it's a case where everybody's got a different way of doing it, you know? And I was hoping that Alfred was gonna be here. I was gonna point to him and say, well, what do you do? And Jim's here and Grant's here, you know? Some of us are big time loggers. So let's go look a little bit about, you know, what to use. I think Grant was a paper logger. Did you log on paper? I think Jim logs on paper. I know I use a computer to log. Dan's an imager, and so that means he probably doesn't log till after the fact, and we'll look at his FITS header files for the images he takes, and they'll say everything he needs to know, and he'll transfer that probably electronically and do it electronically. Ultimately, if you do it electronically, you can do it maybe on a computer, maybe on an iPhone or a phone or a tablet. Sometimes, I think Andy has tried this. I think with his phone, he tries
Voice phone, everything.
voice to text it. And so
Sketch when I can or not having trouble.
now, when you do it, do you do voice to text, or you voice record it and then transcribe it?
I look through the eyepiece first of all, after I've done all my observing, and I think I know what to do, I'll get the phone and I'll describe how I got there, what I see, anything odd about it or interesting. Then the next morning, I'll play it back and I'll go through my written notes, which are usually pretty scratchy, and then type it into my logbook, because then I have access to find out, well, the name of that star in the upper left-hand corner of Orbis, whatever. I'll that's all. Next step.
I will tell people that if you do want to try the voice kind of thing, a couple of programs, Astro Planner and Sky Safari, do have the ability to pick up that voice text and enter it into fields. I think Starry Night maybe has that ability. I'm not 100% sure, but definitely with Sky Safari, there is a way. In Sky Safari, you've got an object, you call it up on the screen. Down in the lower left or right-hand corner, there are like the little buttons, and they'll say add an observation. And if you're in that observation, it will pick up the date, the time, and you can put transparency, seeing, all those kind of things. And then there's a big field, and you can type into the field. We'll need a keyboard, thank you. But you can voice the text into that field. There are some issues with how good voice to text is, but it might be something worth exploring. Ultimately, I use a spreadsheet and I use a computer, and then that's what all those kind of pictures around the edge are. Oh, go back for just a second. In the upper right-hand picture, way up there, is like a digital voice recorder that maybe Andy would use or something. Okay, now.
But no voice to text on it.
No tapes.
We don't have tapes anymore.
Real.
Okay, now, what do you put in your log? And I'm gonna say that first little paragraph right there is that everybody's gonna put in something different, okay? Because if two people use the same equipment, look at the same thing at the same time, they should probably see something different. And I would hate to think what would happen if they both submitted exactly the same thing at the same time to the same coordinator, and that coordinator would say, oh, you guys are piggybacking. Like one person made those observations. Everybody's log should be different. And then down there is a URL. Just to look at. Okay, now.
When you say different, you just don't, you mean more than just a period or a comma, it's different.
Yeah. My wife, the English teacher, was able to pick that up like you would not possibly believe about it. Okay, these come from the Astronomical League on the webpage, and that's that URL that's at the bottom. These are the Astronomical League's kinds of suggestions about what to put in. And I don't see any reason for me to, how can I describe this? I don't think I should have to read these. I think you can read those, Okay, I've got a whole page of other things. Down at the bottom, I do have something that's called Shapley Sawyer. I'll talk about that in a few moments. There's another page, I think, of things like that the Astronomical League comes in. Again, this is going to be in the next newsletter if you want to read it. It's in the newsletter. I promise it's going to be in the newsletter. I said I was going to do it last time. It's in the newsletter.
It will be in the newsletter, and also we're going to post the recording with the deck. So we'll send out a link for that.
Yeah. So these are the things that the Astronomical League gives you suggestions. I have better suggestions, I think, and I think that's this next page. There you go. These are things that I think might go well in the description. Do I put them all in? No. As a matter of fact, as I'm working on a particular program, I'll put these in for some of them, and I'll put other things in others to make them all look different. Now, how come the different colors? Generally, the ones in yellow are required by the program itself. Okay, so you're going to put in the date, the time to minutes, okay, and the location. Location, they generally maybe want to also know latitude, longitude, so do an internet lookup for those. They don't say mount, but I have enough mounts around that I would say it wouldn't be a bad idea to put mount in if you're using different mounts, okay? I'm not as good as Grant with mounts, but you know, mounts. I would think you should say something about the optics, what OTA you're using. If you're using any filters, I put filters in there twice. I didn't do a good job. There's filters in the second column. Eyepieces and what power, if you use multiple eyepieces, multiple powers. They almost always want to know seeing and transparency. One time we'll get around to talking about those two. Seeing has to do with how steady the atmosphere is. Transparency is how much crap's up there. And if you want to do it with numbers and you really want to do it the best numbers, get yourself sky quality meter, and it'll give you a number for transparency. One thing I always like to put in my logs is if the moon is up or not. Because a lot of times if you're looking at something, if the moon's up, you ain't seeing what you're looking for, okay? And then whatever kind of observations you want to have. What's that wonderful expression? A picture's worth 1,000 words. Draw a picture if you want to draw a picture. Me, I'm not a sketcher. There's a reason why I'm not a platinum master observer. There's a reason why I'm not a silver master observer, because I got to do the sketching program. You know, problems with that.
I saw you trying. I saw you trying.
Yeah, you got to do 75 or 80 of them for the sketching program. Yeah, I'm slow. I got arthritis. And ultimately, something that's really, really, really good if you're sketching, try to put in your eyepiece, north, south, east, west directions. You know, but if you didn't do it, don't worry. Nobody said you had to sketch. Did you use averted vision? You know, look in the eyepiece. Do you see? Oh, there's a really couple of really neat double stars over here. Oh, there's this really big star over here. What else could be in the eyepiece? Oh, there's a comet. I remember one night seeing ET with the comet coming through. That was a cool night. If you're a star hopper, you know, how did you get between point A and point B? Where did you start? Now, admittedly, how you exactly got between point A and point B, maybe point D would be a better example, isn't always going to be the same because of field rotation. But still, it would give you an idea if you go back later, give you an idea where you start and how you got there. If you look through your finder, can you see the object you're trying to look at? Sometimes we can. Most of the time we can't. You know, is it better at any magnification? Better at low power, better at high power, something like that. That could go in there. Data on the object. A lot of times the Astronomical League will have the RA and how big it is, and the object type and the brightness and other names. The truth is, if you know your field of view size, you can estimate a lot of that. How big is it based on what you think? If you've got a program that's got some kind of object that moves that you're looking at, you might want to try to estimate what its RA and depth are. You might try to estimate the brightness. You might want to talk about the nighttime observing conditions. Now, I don't think I would necessarily put that down in each and every observation, but you could easily have, on the night of July 7th, you know, the temperature was this, the humidity was what, and you know, those kinds of things. There's my filters again. Did you see any color in the eyepiece? Estimate the field of view and the size. Does it have any definable shape? And the overall impressions. Did you like it? Did you have a good night? Did you see the stuff you were supposed to do? And I will now say, can you think of anything else that they could put down?
That's a pretty extensive list. One thing that I caught was most of the programs that I've dealt with, if you do 2 cardinal directions, you don't necessarily need to do all 4, but they encourage you mostly to do north and west.
Yeah.
And west is so easy because you put the object in the center of the eyepiece and just give it time and let it coast over.
Well, gee, I don't know if my scope is tracking really, really well. I'm gonna have to wait a real long time.
It's turn mode.
Turn mode. Okay.
Turn mode.
Yeah, and he's right about that. You don't have to go north, south, east, west. Usually it is.
But north can be confusing, especially in the knob when you get up there in the north.
Yeah, well, any kind of scope, even like if you use an SCT, because sometimes people here, the SCT is this way, the eyepiece is sticking up, okay? But now it goes some other way, and you decide, I want to stick the eyepiece off this way. Are we all good? That screws up north, you know? And so, yeah, it's a skill that you have to learn. So there are a whole bunch of things. Sorry, that's okay. I'm willing to do that. Now, the truth is, with globular clusters, they do talk about something that's called the Shapley-Sawyer classification. And Dan always puts down Shapley-Sawyer to those globular clusters. The truth is, I'm not going to say much about this tonight, other than to say that next month I'm going to talk about globular clusters in light of the globular cluster challenge to come with in a moment, the globular cluster program and stuff like that. I'm going to talk about Shapley-Sawyer next month. If anybody's Bazoo fans, go like this. Shapley is a tiger. 1915 admittedly, but hey, we can like.
Can I say one more thing here? When I first started the globular program, this had me flummoxed because there's 12 of them, you know, and some of them look a lot alike. But I think you kind of talked me into just look at the middle row.
Yeah.
And is it a 2 or a 3? Well, okay, I'll pick one. And that way, I was pretty close within one in almost every guess I made.
Yeah.
So
it's something to bring up. Okay, most coordinators that I've ever associated with, okay, will not say no to the program if you say something like this wrong. Okay, if you got for the globular cluster program, you got to look for 50 globular clusters. If you don't have one of them right, I seriously doubt the guy is going to say no, go back and do it again. He will say you tried your best.
Your observation, and that's how you saw it.
Yep. And so don't worry about some guy slapping you down. Okay, that just doesn't happen most of the time. And by the way, and what you're looking at for that Shapley-Sawyer, you're looking at the center, say, to see how concentrated the centers are. Okay. If you can do that with globular clusters, there's got to be a way to do it when you do it with the open clusters, and that's called the Trumpler classification. And there's a Trumpler system, and sometime we'll get around to talking about that. And so it's based on the degree of concentration. You know, is it this or is it this? It's how brightness goes across the field. Are they all about the same? You see lots of variation in brightness, and then the number of stars, whether I think they're less than 50, between 50 and 100, or more than 100. And then I think I have a picture showing some examples. Screw that. Go to the next one. And so there are some examples of different open clusters showing that. I point those last two things out, Shapley-Sawyer, Trumpler, because if you're going to work on more astronomically programs, you're eventually going to bump up against those. And if you're going to bump up against them sooner, and then you can use those for your observations. Okay, and then they do really put a whole lot of stuff together. You can go ahead. I do keep my logs online. I have for years and years and years. Google did cause me some problems when they switched over, and I have got most of them converted over to the new Google format. And so if anybody's interested, those are real life links. And that very first page had a URL to this PowerPoint. So if you would download, if you click on any of those are some of the ones that I did. And by old format, those are the old before Google messed me up. And then where I got new format, those are the new ones. I think that's it. Oh yeah. And if you don't know how to calculate the true field of view, a truthful statement is that if you were an observer last century, before all this and all the digital stuff, and you could look all that stuff up, you had not a clue what your field of view was until you measured it. And so what you would do is you would go out on the field, and you would take your telescope, and you would take an eyepiece, and you would put the eyepiece in it, and you would put an object on the east side of the field, and you would let it drift across, and you would time how long it took the time. Okay, and you would say, oh, it took 2 minutes and 30 seconds. I can do the math here, 210 seconds, sorry. And based on that and the math little formula down here, you can figure out the field of view. And so if you say, oh, it's a third of the field, and if your field is 1 degree across, then what's a third of 1 degree? It's, 33 minutes. And so you can report those kind of things. And I think some people are impressed by that.
That's the last slide. So
That's the last slide. Actually, there are 9 programs that have to do with binoculars, okay? And I'm probably going to miss one, but in no particular order. There's a binocular Messier program where you look at, I think it's 50 of the brighter ones, and you get to pick the ones you want to do. There's a binocular variable star, no, not that level's later. A binocular double. I got to do it in my mind. Deep sky. In the binocular deep sky, there's 60 of them, and there are lots and lots and lots of open clusters that happen. There's a binocular double star, which are double stars that are a little bit further apart than you can see with binoculars. There's a binocular variable star program. a binocular. Well, I'm gonna say Southern Hemisphere one, and then as part of the lunar program, as part of the solar system program, and something else. There are certain parts that you get certified to do those. So yeah, there are things that you can do with binoculars. And when I say with binoculars, for the most part, you don't need the club's 25 by 100s. I'm talking about, in a lot of cases, 1050s or something like that. You should be able to do it.
I think 10 by 50, you can get most of the first 50.
Oh, and I should explain and say that if you go to the Astronomical League's website for binocular nesting program, down at the bottom, they say, hey, if you have binoculars that are 750s, look for these. And if you have binoculars that are, look for these. But with more high-powered binoculars, you look for different options.
All right, thanks, Steve. All right, so now we're going to go into the main presentation. Let me get the camera and everything going here.
Excuse me. Is that your cell phone?
That is not my cell phone.
Oh.
All right, so I gotta take what I've got up here down real quick and bring up a whole different one. 1 second here.
I can give you some background. So I put this presentation together. The Kansas City Astronomy Club, after they sat into my presentation on.
Well, hello, everyone, at the Kansas Astronomy Society. I'm Professor Stacy Cotter. I'm an associate professor of physics and astronomy at St. Charles.
So what happened was I did my PowerPoint presentation, and then I was supposed to do the presentation live. It turns out I had to go to camp that weekend, and I was afraid of bad internet. So I recorded this ahead of time in case the internet was bad. The internet was indeed bad. And when I went back to pull up the presentation by itself, all I could find on my computer at home was this version with the video already implanted, and I can't pull the PowerPoint back out of it. It's running in PowerPoint, but I recorded the video in PowerPoint. So my PowerPoint slide is encapsulated with this. So I thought about wearing the same shirt tonight and pretending that I was doing it live. But what we'll do instead is, if you have any questions, we can pause it and I can answer them live as we go through the presentation this way. So it's a little bit weird. I had planned on doing the live presentation, but I couldn't remotely access my computer at work where the actual PowerPoint slot saved. So this is the only one I could find that sent it in. So, but it's an update on Perseverance and a little bit of background. Not only will I talk about Perseverance, I'll talk about how Curiosity led us to some information about Perseverance, how the other rovers and some of the orbiters.
Mars stopped being geologically active.
Did that on his own.
You got to go back a slide to do the other one.
All right.
So, but anyway, so once it gets rolling, it's okay. You only have to pause it once when there's a video I want you to play in there. I'll tell you when to pause it.
Okay.
Other than when anybody else wants to pause, because like I said, all the screen changes and everything are embedded in the video. So we can't go back and separate the presentation from the video part of it. So, but we can pause it, and then you can ask questions if you have any questions.
Yeah. And I'm fine with you not wearing the shirt, but I want that Superman lock hair.
Isn't that cool? Yeah, that was cool. Yeah,
All right.
I've shortened it since then. But
So just as a sound check to
Mars
those
incredibly
on,
cold.
all right,
Incredible.
for those on Zoom, can you hear Stacy talking as part of the video, not live?
yes.
Yes, I can hear you.
Yes,
I know there was
yes,
issues
yes.
about- All right, so let me see if I can go back here and start over.
Yeah, but the lower left.
Then to the lower
When
left.
you hover over here, the lower left should have the back and forth. You must have paused it or something.
Oh, this is the, yeah, 1 second, let me,
And
Let me-
while
let me
he's,
get
while
out
he's
and start
fixing
over.
it, I'll tell you that there's a couple of times in here when I watched it back, I would sometimes say Curiosity when I meant to say Perseverance, because I was comparing the two and the data we got from one versus the other. And so I mixed them up when I said them. So please be aware that that happens a few times in here.
Yeah.
And then the last thing is there's kind of a faux pas I made at the end when I talk about the power source. I'll correct that after it's over, but the power source of the rover. I just tossed it off because I meant to say something more complete, but I'll clear that up at the end of the presentation.
So be kind, folks.
Be kind, yes,
All
because I
right,
didn't have a chance to go back and read it. So,
here we go.
Mars incredibly cold,
nope, you go back a couple
incredibly
slides.
cold.
I thought it
With
started.
no magnetic field, it's not.
Okay, I'm throwing
So
off.
of course, I'm giving you some Mars background and some, everything that leads to how the scientific method is trying to be used to get our information together towards the goal of actually putting.
Hello, everyone at the Kansas Astronomy Society.
I'm just gonna let it go.
I'm Professor Stacy Cotter. I'm an associate professor of physics and astronomy at St. Charles Community College near St. Louis. Some of you may have seen me from your visiting our Alliance for Astronomy group here in St. Louis and attended our video presentation. If you're seeing me for the first time, I'm appearing for you recorded. Unfortunately, I planned on being live, but the area I'm finding myself in on Saturday has spotty coverage. So with any luck, I will be also zooming in on the phone, which requires much less video, to answer questions for you after they play this video for you, if you have any questions relating to it. Hopefully the bandwidth allows me to do that. So that's my intent. If you're hearing me now, you'll probably get a chance to ask questions in about 20, 25 minutes or so when this presentation is over. As you can see, the topic for today is Mars, specifically the Perseverance rover in what's happened up until this date in 2022. Of course, it started way back in 2020 when we had the launch and everything. So a little bit about the background of Mars, which I'm sure you're mostly familiar with, but I'll be talking about a little more complicated things today. So I want to make sure that we at least touch base on some of the very basics. And so when it comes to Mars, the first thing we want to know is that Mars stopped being geologically active billions of years ago. And as a result, unlike Earth, who is constantly replenishing its atmosphere, keeping things just wonderful, other than human intervention, as we know, Mars has died. It does not recycle its atmosphere anymore. As a result, its atmosphere is incredibly thin, only about 7/1000th that of the Earth's atmosphere. It's made almost exclusively of carbon dioxide, over 95%, but it doesn't provide much greenhouse effect, of course, because it's incredibly thin. This also has the effect of making Mars incredibly cold. Okay, incredibly cold. With no magnetic field, it's not protected from the solar radiation. And as a result, we have no Van Allen radiation belts to protect us from primary gamma rays like ours do. And we do, unfortunately on Mars, get some secondary effects because while the atmosphere is too thin to afford a lot of protection, it's just thick enough to interfere with some other radiations and cause secondary effects. So we're concerned about the radiation effects on Mars as we plan to send people there in the next decade or two. And so we're trying to get a lot of background information from the Perseverance rover specifically for that. There's things that have gone before, there are things that follow after, so I'll give you a little blueprint of that. Of course, as I mentioned here, it's also incredibly cold. Sorry, my pictures interfering with some of our animations down here on the side. But I am making this presentation also available to you directly if you want to view the thing in its entirety and see some of the things that might be covered by my video picture. So, as you probably know, we have a launch window to Mars every 26 months, which makes it challenging. Some people who are big Mars aficionados have said in some way that they anticipate dozens of launches weekly to Mars. Well, we know that's not going to happen because that would be an incredible amount of energy to send people by the most direct path when the moon and the Earth and Mars are located on completely different sides of the sun. Obviously, that's going to be a no-go. Here's a little animation from NASA's JPL showing the close approach times when we launch. We're a little bit ahead of Mars when we launch generally, and we let it run into Mars as Mars catches up to it. So that's the way we normally send things to Mars in every 26 windows. Even when we do this, there are different types of paths: low energy paths, which are long time paths, short energy paths, low energy paths, which are long time occurrences. And so as a result, in our future, we'll be targeting the path and the time, of course, to whether it's a human involved journey or just a object involved journey. You can see the link here I used to find this animation and some more things that you want to go along with that. Just to give us a timeline of what NASA's current plan is relative to this and where Perseverance fits into it. Of course, we're Earth reliant missions are where we started with this, mastering things about the International Space Station, just dealing with life and getting the public involved in making rockets. Now we're in the next stage, we're the proving ground, right? We're launching and returning things to Earth in a computing manner and setting up the Space Launch System and the Orion spacecraft for return to the moon. And then eventually, after we return to the moon, then our goal is to move onward to Mars. Timeframes are very flexible on this, but it looks like we might be somewhere in the 2040 realm if we stay on target, probably a little bit beyond that, but that's the goal anyway. So right now, before we sent the Mars 2020 mission, which is the Perseverance one, I call it 2020 plus because of course it's been ongoing for years and will continue for a while yet. There's a picture of the Perseverance rover. The Perseverance rover carries more scientific instruments that have landed on a planet than all the previous missions together. That's quite an accomplishment. So basically, in terms of mass, this one rover has more scientific instrument mass than all of the scientific instruments we've landed on all planets other than Earth.
Wow.
So this was quite an accomplishment. I'm sure you're familiar with the Sky Crane. I don't have a video to remind you of the Sky Crane's amazing stuff, way that we landed. But we cut our teeth on the Curiosity rover, and so there's a lot of things that we learned from that. That landing in low atmospheric conditions is not like landing in no atmosphere. We still need a heat shield and things like that. But because of the lessons that we learned, we were able to include a bunch of different instruments, including 7 science instruments. And they all have fancy names like this: Mastcam Z, Supercam, Pixel, Sherlock, Moxie, Lita. And most of them are just so that people can say, well, what does that name mean? Right? I'll explain the major ones that go along with this one. We don't have a lot of information on the Lita yet, and the Supercam gives a lot of the same data as the Mastcam in just a more complete detail. So a lot of times the visible cameras versus the instruments, right? We break them down into that subset. So we'll talk about the contributions of these things and what we found with the Perseverance rover. Once we have a little more background, then we'll slide right into the Perseverance rover. And again, if you want more details on these instruments and what they specifically do, here's a link from NASA's website that can help you with that. So where did Perseverance land? It landed on Jezero crater. Let's see if I can get my animation to play here. There it goes nicely.
And then play that guy up there. And then he's gonna talk, like he's playing us on. I'll mention it in a second.
This flyover was produced from NASA images taken from orbit. The blue circle indicates the area the rover will likely land, with the arcing hills in the center, about 1,600 feet high over the rim of Jezero crater. The true goal of Mars 2020 is to learn whether life ever existed on Mars. It's too cold and dry for life to exist on the Martian surface today. But after Jezero crater formed billions of years ago, water filled it to form a deep lake, about the same size as Lake Tahoe. Eventually, as Mars climate changed, Lake Jezero dried up and surface water disappeared from the planet. An ancient lake is a fantastic place to pursue our goal of looking for possible Martian life. On Earth, lakes are filled with living creatures. Evidence of that life is often preserved in the mud and sand deposited on the bottom of the lake. So, we use the rover's instruments to explore the rocks of the ancient lake bed. Here we can see evidence of the former lake. The canyon cutting through the crater rim was carved by a river. As the water entered the lake, it slowed and dropped the sand and mud it was carrying to form the fan-shaped delta. The white line is the path the rover might follow in its first 2 years, called the prime mission. During this period, we used the rover science instruments to analyze the lake sediments. After we explore the delta, we hope to investigate the shoreline of the former lake. To get there, we have to traverse around a sea of modern sand dunes. From this perspective, you can see former shorelines curving around a headland. We can picture waves in Lake Jezero beating on a sandy beach. And finally, we will press on to the crater rim. Jezero crater formed when a large object collided with Mars, excavating rocks from deep in the Martian crust, exposing them in the rim for us to study. These rocks would have been hot shortly after the impact and may have hosted hot springs. Deposits from these springs would be another target in our search for possible ancient life on Mars.
Event.
Go
So-
back to the slide, next slide.
Part of the job of curiosity.
Now just shut that guy. Let me talk.
Shut him down.
Shut me up there.
Let me talk.
Perseverance landed. It landed on Jezero crater. Now let's see if I can get my animation to play it. There it goes nicely. And so this was the landing site, and it's a flyover. It's not an actual flyover. It's put together from global orbiter images and things like that. So NASA does a really good job of stitching these things together. This was not the landing image, right? And if you do listen to just the PowerPoint presentation back, I did include the clip in total from NASA. So including the lead scientist will tell you more about Jezero crater and why it was selected as a landing site. But essentially, there's a difference between Gale crater, where the Curiosity landed, and Jezero crater. We wanted two different geologies to explore different aspects of it. The goal of Curiosity was water-based and can do as much geology as it can to try to find water. The Perseverance rover was designed more specifically to look for the signs of life with more complicated instruments than were able to be put on Curiosity. So we chose a different location because we're looking for slightly different geological signatures than we were looking at Gale crater for the Curiosity rover. So this is a nice animation showing you to scale some of the things. And basically, Gale crater has this meandering path, a lot of exposed rock that we can see. And then the major advancement in terms of mechanical advancements for the Perseverance is a drill, a very powerful drill that can drill into and slice off portions of rocks and be able to look through the abrasive layers and see what the rock's construction is visually. And then that high-res camera has the ability to take very high-res images in visible light that can tell us a lot of things in very short order without needing very high science details behind it. So we all know a picture is worth 1,000 words. And in this case, a good picture is worth 1,000 instruments, at least as far as it's saying. We don't have to wait and say, now, is that bauxite? What type of mineral or what type of compound is this? When a geologist with a high-res picture can tell you with 99% certainty which type of rock it is. So that was one of the best advantages of this new.
New what?
We need next
Buffering,
week.
must be buffering. No, you got it loaded on you.
Yeah, it's on my computer directly.
So part of the job of Curiosity was also preparing, it's all prepared for human spaceflight. So Curiosity had a radiation sensor that they wanted to learn about the radiative effects. Of course, this could also affect the scientific instruments on board Perseverance. So they looked at the radiation findings, and they did something I thought was really smart. They actually turned the radiation meter on during the travel from Earth to Mars to get the inter-solar system effects of the galactic cosmic rays to see if they were substantial and if they could be protected simply from the structure of the cells. So the radiometer is pretty deep inside the package that was delivering Curiosity to it. And as a result, they said this could simulate the shielding we might be able to create for people. And they were able to get these pretty good mappings of the cosmic rays. We're concerned with two big things. This is, you can see there's a dose equivalent for basically how many REMs you get per year compared to what's on Earth. There's a safety limit and things like that. And the Mars cosmic ray environment shows that the cosmic rays concentrate in different regions, right? High regions here surrounding these locations and lower regions to the polar regions up here. And so we got some of this from the global surveyor mappers and some of the Curiosity as it was still in orbit. When it landed, of course, then the radiation sensor was deployed, and we put a bunch of this information together. They didn't do as much of this with, there's no radiation detector specifically on on this one because Perseverance, because they knew they'd have a lot of data from Curiosity to parse through, and they still are. The paper that I'm quoting you from Curiosity was just published last year, even though Curiosity has been around for many times. And what are the radiation findings that could equate to problems today? Basically HZE radiation. And it's a fancy name for nuclei that are greater than Z2. If you remember your basic atomic information, the atomic number, the Z number, basically the number of protons. So basically an element more massive than helium. Hydrogen is 1, helium is 2. So there are some of these elements around in the radiations in the solar system, and those guys can cause problems to us. The other type of radiation that can serve is the SEP radiation, solar energetic particles from the solar wind. There's a lot of those. And the problem with those is it'd be one thing if they made it directly to Mars, because Mars had no atmosphere. But the problem is Mars has just enough atmosphere that, just like the Earth's atmosphere creates a cascading effect with galactic cosmic rays, the galactic gamma rays that try to get through our atmosphere and our magnetic field are stopped, absorbed, and they create secondary components that are less harmful to us. And they help us study what they would have been above the atmospheric effects. Unfortunately, they create more forms of bad radiation when they interact with Mars's relatively low environment. So when that radiation sensor got to the surface, it said, well, these are higher levels than we expected to see. And so from this, they've come to the conclusion, at least in the paper I read, that we need more protection in space and on the surface of Mars if we're going to send people there. And they gave the quantity of 2 kilograms per square centimeter of mass of rock between you and the surface of the planet. And so that equates to about 2.5 meters or 8 feet. So NASA's plan for initial habitations is to scout out lava tube areas, ones that we can kind of shuttle in from one end and have hopefully 8 feet or more of rock above us. And that would prevent a substantial living environment. Now, of course, we're going to have to do better than that with our initial stuff. We're not going to be able to find and move into lava tubes right away. So they are devising more radiation resistant enclosures for smaller groups of astronauts to live in. But it's a big concern going forward, and one that Curiosity pointed out would be an issue in the not too distant future. So now that we've discovered, we've taken us up to Perseverance itself, you can't really learn about something about what learns happened before it. Let's talk about the mission summary today. Okay. So after landing and deployment, we're heading up Jezero Crater. Along the way, we launched the drone. We had fun with the drone, right? And the drone went really well. We didn't get a lot of scientific data from it, but we got a lot of proof of concept stuff. The drone was really about, well, it carries a camera, it has some nice videos you can get on that stuff. It was really about proof of concept. Are we able to master something flying in a room? Because remember, this is not live control. There's a minimum of at least a 15-minute delay between command and receiving of the command. So the drone was autonomous. It flew on a pre-programmed path, and it did very well, and recorded images as it did so and landed safely. So we're very happy with the performance of the drone. And again, it was more a proof of concept thing, and will probably be used in the future in a more substantial way than it was here. So kind of like the sky crane method was used for the lighter Curiosity probe, it then became proof of concept. We're using a much more massive sky crane to land Perseverance. The same thing will be true of Perseverance's drone. It's kind of proof of concept for the next set of drones that will be coming along. Okay. So that's the first thing. And then, of course, we have the results of the surface studies, the things we found on the surface. And in addition, we'll also have the results of the atmospheric studies. So there were things we learned about the atmosphere as well. Not as many, because we've been able to study the atmosphere pretty darn well from orbit. So we didn't need as much of that from landers that couldn't move, because the atmosphere, of course, moved itself around here. But so most of the summaries here will be on surface stuff and not as much on the atmospheric studies. So the surface updates that were the surprising results that we found as the rover trundled its way up Jezero Crater is, and we'll study each of these in detail as you can see in here, is that the bedrock formed from magma. And while that was an assumption, we know that the northern half, the northern vastness of Mars, was volcanically formed by a big split of Mars, probably by a large seismic event that cracked it open, flooded the northern hemisphere and loaded it. And the southern hemisphere was older, and as a result, we knew Mars has thick plates, and we didn't think it had a lot of plate tectonic activity because of the thickness of its plates. But the bedrock being formed from magma makes us think that maybe it was a little bit more, so we'll talk about that. Likewise, the material has been affected by water multiple times. This kind of flies in the face, as we'll mention in a little bit, that there was one cataclysmic flooding event, and then when it ended, it lasted for quite some time and then it died. It appears that there might have been more than one, and we'll put to the evidence of that. 4 organic molecules were found. Don't put thinking organic as biologicals, right? Organic simply means long strings of carbon, right? Propane, methane, butane are all long strings of carbon. When you start hanging oxygen, hydroxyl groups and things from it, then you start getting organic molecules. So organic molecules, no biologic shit, but organic molecules is found. And then the big one, some of these things weren't possible without the new instrumentation, is the subsurface tilt matches the surface tilt. And I'll talk about the importance of that as they come along as well. I'll get each of these. Okay. So now here's the slide on the red hot magma. There was a rock they called South Seta, and Seta, I know I'm not pronouncing it right. You probably heard of another rock they named called Brack, right? They talked about Brack a lot in a lot of the other ones as well. But the South Seta rock was sliced into with the drill and subjected to analysis by Pixel. Pixel is an acronym for X-ray lithochemistry, right? And lithochemistry is basically geology, the lithosphere, the rocks that make up the striations of the combined mineral rock composites. And so X-rays are able to peer into that in more detail and see the structure. Okay, so that's Pixel's job. Pixel's job is to use this little X-ray sensor, drill into it to slice off pieces, get a good section that they can peer into with the X-rays. And it found olivine. Olivine looks like this. I have a little sample for you here. Olivine is a pretty common mineral on Earth, and this has this greenish color to it. That's what gives it its name, olivine. Right? Here's another sample where it's mixed in a little bit more and more complex rock matrix. Not sure how well it's showing up on the camera. I'm trying to make it show. With the blurred background, it's getting a little blurred. But olivine crystals in pyroxene. And what that means to a geologist is that it indicates that that can only form in cooling over a long period of time. So that's where the red hot magma must have once existed. To get the olivine crystal structures we found in the pyroxene, the only way that it could be found is in cooling over a long period of time, such as magma. And so that's the kind of smoking gun, if you will, that they have been able to verify with the instrumentation of Pixel aboard here. It was hinted at by the cameras on Curiosity, but of course, without the proper instrumentation or the ability to drill deep enough to find into the right sample, the right substrata, you couldn't verify it. So that was the importance of getting the Pixel up there to do this lithochemistry. So it has paid dividends already in giving us confirming evidence to what we supposed had happened. But it was a little bit surprising, as I mentioned, because of the fact that we didn't expect there to be as much in the southern hemisphere, because we believe the thicker crust had forced most of the volcanic magma formation into the northern hemisphere. Surprises are good. What about the multiple water erosion events over time? Okay. Well, as you probably know, rock reaches its current state, and it doesn't just spring out unaffected forever. Mars, while having a thin atmosphere, does have an atmosphere and has erosion. And back in the day, it had a much thicker atmosphere and running water, which can cause erosion effects by both wind and water. And this was one continued event over a long period of time, that would show one change to the chemistry. So there might be, say, mineral deposits that happen as a result of water flowing over it from the same period of time. One eruption of a source of subsurface water from a big aquifer of some type would flood the surface and then keep that water moving. If it then ended to settle over this area, the chemistry would induce the same type of mineral deposits over the same period of time. It requires a change of some type in order to get a different mineral deposit. And that's what we found. we found that when we looked at the location of various minerals within the rock, those minerals had to be formed from multiple immersion or water-related events. So something happened at some time, and maybe it was covered by water, and the water dried up, and then it got covered by water again, and the water dried up. Maybe it was just the chemistry of the water changed, but of course the chemistry of the water change could be due to, say, an underwater volcano, putting new material in, creating ash or something to change the pH level of it. And the other ones, I'm not a astronomer, right? I don't study the geology of astronomy, just have the basics of it. But effectively, this multiple immersion events are responsible for creating these different layers and strata of minerals that we found in the rocks strewn along the path of Jezero Crater. So that was a very important one. This was kind of, through scientists, a little bit of loop. The generally accepted model, as I said, generally says less volcanic activity in the sound. Flooding was probably one large time event, and now it appears it could have been cyclical in a couple of different events, or some other events happened to change it, which means, of course, it was geologic activity. Can't have a change without some sort of geological activity making the change occur, right? Other than, say, in a collision event, large meteor, something like that. Okay. So that's the multiple water erosion events. And then the other thing we found was organics everywhere. So again, harkening back to curiosity, we found organic molecules, which are chains of carbon atoms in Gale Crater, which is where it looked. But Gale Crater has a different chemistry, right? So we wanted to say, hey, was this specific to Gale? Is it the same at a different location, or is it slightly different at a different location? And by picking very carefully, we went to a place that had a substantially different geological construction than Gale Crater. We didn't want to just find the same place, we wanted to find a different place. Then any similarities that existed would be generally considered to be due to the fact that this was a more common occurrence, regardless of the local conditions. And any differences would generally be due to the fact that different things happen due to different locations. Things happen differently in the desert than happen in the jungle, right? So different things would happen in a Gale Crater geologic structure as compared to a Jezero Crater structure, but there will be some things that are common to both. So that's why we wanted a slightly different structure to see where that led to. And this is where we use Sherlock, right? Sherlock has a very fancy name to go along with it, but it basically looks at both the abraded rocks and the dust, right? And so it shaves away at a rock. The laser, the drill shaves away at a rock to abrade it to make it surface. And then it samples some of the dust from it, has a little dust collection too. And Sherlock has found these organics as well. Sherlock is the instrument for finding organics. So Sherlock stands for organics. And it has verified similar and some different ones. So that's basically not a big surprise, but it is I would say a welcome verification of things that we accepted. We would expect that if organics behave this way, where there are some similarities and differences, they could eventually lead to some form of life with the proper conditions. So that's where we validated the curiosity findings with Sherlock so far, with some exceptions that are only pointing out the fact that while some things are same and some things are different. So then we have this guy here, and this is, I apologize, my picture's coming over the edge of this thing, but this is the slide that talks about the surface tilt matches the subsurface tilt. Okay, RIMFAX, as you can kind of see, the R in RIMFAX stands for radar. And so it's a very powerful radar that can look up to 10 meters below the surface. This is the actual imaging we saw here. And you can see these striations along here, and at different parts of the journey, it looks along the journey and it says, okay, here, what's it look like down here? What's it look like down here? And so as it moves along, remember, these are not incredibly great distances. You can see that it moved through a region here where the terrain went down between T2 and T3, then it started to go back up again. So this is kind of like a mini little valley on the surface in your way into Jezero Crater. And as a result, there are these striations. It passes periods where there's a high density lithostructure. But notice how the tilt is contained here. And the rocks that have the same tilt in them as the tilt that matches the tilt of the subterranean rocks. So imagine you had two rocks like these, right, that were below the surface. And one of them was moving in such a way that it forced the other to tilt up, right? So if this were all formed into a structure, this is just a piece of marble, right? Then the striations, if it were a large event, all the striations would point in the same direction. Not just the surface striations, but the subsurface striations, right down below and above. Because it was part of one big large event that tilted the whole thing, okay? Which would be a large geologic event, as opposed to a small event like a rock rolling down a hill, right? If a rock rolls down a hill because it breaks off from something, then the striations could be at a vastly different angle than the rocks that they're adjacent to. And then, of course, if it settles in through erosion, it settles in, it can look like it's a part of the subsurface rock. And is it tilting because it tipped over? Or is it tilting because it's raised up and a part of a much larger rock? So what they found is some of these structures are parts of much larger structures. The RIMFAX use the radar to look down into the substructure, and the substructure matches the superstructure, the stuff we see up above. So it's a pretty incredible little piece of work to answer the question about the geologic activity on the surface of Mars. It's very important, very crucial to look for.
Yeah.
So that's the surface tilt matching the subsoil.
Question, Grant?
Yeah.
So that's this.
That was it. Yeah.
Back that last slide, please.
Make me work
You
at
have
it.
to pause me again too, because I'll start. talking.
Yeah,
Okay, that's good.
those
Okay.
darker in your radiograph.
Yeah.
Those darker areas that come up at an angle.
Right.
That's your tilt.
That's your higher density, yeah.
That's your
And
higher
see how
density.
see how the tilt is maintained in these long string bands over and over again, kind of like the belts of X zones on Jupiter.
Right, but when you go to Grand Canyon, you just see that stratics kind of, some of it is.
Right, okay. And because this was not seeable, that's what the part above and below, that's what I was trying to show with the rock, could have been the stuff that just shifted on its own, rolled over, and then embedded itself in the substrata, and you couldn't tell. So they had to find a way to image down below to make sure these were large scale events and not just tumblings, to identify the rocks that fell off and broke apart versus the rocks that are lifted up from the substrata. And you can see this is only over the span of 60, 70 meters. You know, the rover does not move fast. It takes a long time, takes its image and moves on. But yeah.
So now you got this layering. Now, that at one time, that was surface. The layers represented surface. And over geological processes became tilted, right?
Right, the geological processes cause uplift. Most of this was, when it tilts this way, there's usually an event that lifts it up in this direction.
Right. So now if you
Or
go
sinks it
across
on
the-
this side.
And then as the rover goes across the surface of that, it's able to sample all of those prior errors, right?
Yeah, it stitches them all together. It takes it, it's kind of like when you make a composite image with your telescope, you got too big an object for one field of view. They stitch a bunch of it together and then overlap the overlapping regions.
Right, and so my point is, so as you go from left to right, okay, right underneath T4,
Yeah.
you're sampling that middle band.
Right.
Look, go off to the right to where 201 is, now you're sampling that fourth band below.
Correct.
So now you've sampled a couple of geologic errors
Yes.
in that one.
That would
And
be
of
correct.
those errors, are you finding commonality or are those errors?
The RIMFAX only gives you the data on the composition of the materials. They think they can get more data, parse this apart, because they know the higher density regions come from depositions, if it's rather sedimentary versus metamorphic rock, the different type of rocks that come from it, the striations come because of different effects. So they have to parse into the data even further to see the types of rocks. And that's the key thing though, the rock exposed on the surface, they can tell. Was it sedimentary or metamorphic? Boom, we got a visual image, they can drill into it. Now that they know it's a part of the lower substructure, they can take that down and say, so that is the same. So in the case of metamorphic, if it's metamorphic on the surface.
So they weren't intentionally they weren't intentionally sampling like every 100 yards.
No, this is every couple of meters. It stops every.
No,
couple
on
of
the top, on the top.
Oh, on
To
the top.
get that cross-section sample.
No, to get the cross-section sample, they stop, every time they stop, every instrument gets a shot.
Right.
The RimFax shoots down, the Sherlock shoots, the mass cam shoots, they all parse around and do their job to that location. They can't fire them all at the same time. I'm talking about the power consumption considerations coming up here, but they all get their shot before they move on to the next location.
So probably over here at Washington, there's some PhD candidate going through all that data going, I bet I can do this.
Yeah, very likely.
I can do it.
Yeah.
Are they expecting to find any ports?
Anyway,
Ports.
false?
Yeah.
Yes, they found some already. They have
By
found
the time they think that they're not finding.
exactly. You're not going to find it right. They found evidence.
But
Evidence
that
of-
means that they're manipulating.
Well, correct, right. And that's what they hope to, when they get, like I said, RimFax can only go so deep, can only go 10 meters deep, which is not a great depth to see fault lines. They might get lucky and come across one, that is like one of the big highway cuts you see out in California when they're put into a fault, but they have to get really lucky in order to see one like that. But they would be able to detect a relatively close surface fault if they could find one. But of course, we all know that, well, they know that there are tectonic plate, there's movement of these rock structures due to some undersurface effect. And so a lot of times it's molten, pushing up and sliding apart. Sometimes it's because of a cratering effect, can actually cause some of the rock to shift. Mars is a big shock cones and all the things that get ejected from meteor sites that compresses the material down below. Doesn't show any evidence of that type of compression, but that's just an example of things that can happen and change the strength.
What your matter with energy for. I mean, we know that there is common organic matter we find in meteorites. Right? So they should put it for something younger because according to the theory, I mean, we find it here and there. Right.
And we've had, of course, we had a few of those, the Martian meteors. that came
Yeah,
along.
that's interesting. As you say, the rocks from Mars that came to us. I mean, you know how it happened, but it's speculate.
So that's the surface stuff. The atmospheric stuff, like I said, is curiosity to a lot of atmospheric stuff. A lot of the global surveyors and the atmospheric probes have learned as much about Mars's atmosphere as we can, as groundbreaking stuff. There's really not a lot of ground-based stuff we do. But what they did include in this mission is something very interesting relative to the atmosphere called MOXIE. Right? And the OX in MOXIE stands for oxygen. It's an oxygen plant. Yes, they are grabbing the atmosphere, not the surface, literally grabbing the small amounts of atmosphere from Mars and making oxygen out of it. Of course, oxygen can be used as an explosive for propellant, and oxygen can be used to breathe. Now, this is a small scale model, and by small, I mean it's about 17 kilograms, right? So you're talking about 40 pounds, which is, like I said, substantial. This rover has more mass in scientific instruments than anything else we've done before. And so MOXIE uses 300 watts of power. Okay, you think, oh, that's not too bad, 300 watts of power. And they use it, as I said, as its mass of about 17 grams. It's made up to about 7 grams of oxygen per hour. May not seem like a lot, and it's not. But it's, again, one of those things where it's a proof of concept type thing. And it's amazing how much time and effort goes into scientists when they think about these things and how much work they do. But think about it in terms of the energy consumption, right? I mean, 300 watts isn't a big deal, but 300 watts is a big deal. The solar panels on Perseverance.
See, that's what I was going to say. That's where my faux pas was. It uses an RNG. Fred gave us a big talk about RNGs last time, radio generators that basically use and we didn't have the plutonium for it. We had mined, I guess we're still moving on, that's okay. We had mined plutonium for 50 years. We had to make 50 years, so we had to make plutonium for these things as power sources, and they give off a nice constant about 110 watts of power, as you'll see it here. I meant to say that we learned from curiosity, not from curiosity, from Spirit and Opportunity, that solar panels are not the way to go on Mars because all the dust in the atmosphere, the dust storms that blew up over will abrade the solar panels, make them less effective. All those things are going on. So there were no solar panels here. I apologize. I don't know what I was thinking in my head when I said that, but it's the radionucleotide generators that, RNGs that power this console.
So I stopped you, but this kept going, so I don't know.
I think that's fine.
Experience only make about 110 watts of power, right? So it can't run in line. It can't just run off its own source. Of course, there's an internal radiating source as well. But as a result, you have to, this amount of oxygen will only sustain a person for 12 minutes. So in about, it's ideally, it was designed to make up to 10 grams of oxygen per hour. And so at that rate, of course, you couldn't even sustain one human because in the best they could do, even at 10, you would only be able to sustain somebody for about 20 minutes, and that would take it an hour to do. So you need something much bigger than this, even to support the oxygen needs of one person. And as I mentioned, all other major activities have to be stopped because the power that the power source and the solar panels can supply to the rover at any time is only 110 watts. And MOXIE requires 300 watts. So it runs off the batteries, right? It stores batteries and it discharges those batteries while shutting down almost everything else to run. But fun science. So while they were waiting for, they knew, of course, that the moons of Mars would eclipse the sun, and they happened to be in a position where Phobos, the larger of the two Martian moons, eclipsed on April 2nd, right after April Fool's Day. I was thinking, oh, it's a joke, it's going on April Fool's Day. No, Phobos was actually, and you can actually look at the sunspots. Right? Now, remember, this is just the regular mass cam. This is the high-res camera because that one's a little more sensitive. They don't risk it. But they literally just pointed this towards the sun, and at this magnification, you can clearly see sunspots. It's not a great resolution, it's not high resolution, but you can actually see some of the structure of Phobos as it goes forward. So, and of course, they're using this for studies to help understand a little bit more, but it was not the original intent. But often you take advantage of opportunity, right? And so while this wasn't originally in the plan, somebody had realized that, hey, it's going to have an eclipse from its site. And of course, eclipses happen much more often because of the shorter orbital periods of Phobos and Deimos. So as a result, you get a lot more opportunities for it. But as you can see, it's not a total eclipse, but it still looks pretty darn interesting. And so that's where the last of the information that I have for you on the mission was from today. So hopefully you enjoyed the presentation. If everything is going according to.
Stop the rest of it. So sorry. So that was the end of it. So if there were any other questions you had in between to talk about, but I always thought that was fun because that happened. I was putting this presentation together in April and they had just gotten that image back. I said, oh, that's a really cool one. So that turned out really nice.
I have another question.
Sure.
Did they speculate what the composition of the atmosphere that would be warm enough so we would have water running?
Yeah, they believed that at one time it had a very similar Earth-like atmosphere. They believed Mars was incredibly geologically active for its size for a relatively short period of time, and it thickened the atmosphere so much that even the decreased solar energy making it to Mars because of existence was more of it was kept because of the much thicker atmosphere it had at the time. And so that's what they believe substantiated for several million years to allow these water events and things to happen on the surface of Mars. So really, initially and again, it's all in flux as we get more data. That's the event. That big event basically vented most of the stuff in the atmosphere. One big loop. And Mars is like a leaky bucket. I always tell my students, Mars is like a leaky bucket. It doesn't have enough gravity to hold on to atmospheric components of this mass. You need much more massive ones for it to hold on to, which it doesn't have. So if you keep filling a bucket with a hole in it, you can keep the level up high enough for a while, but eventually once you stop filling up the bucket, it's going to leak out. And that's what happened with Mars. It had strong enough geologic activity to flood its atmosphere and make it really thick. But because of the lower mass, of course, and the cooler temperatures, that mass was slowly stripped away replenished while it stayed geologically active. But when Mars cut off sooner because it had less internal heat, then the atmosphere just fades away. Oxygen, water seeps to the outer edges of the atmosphere. The solar radiation splits the hydrogen from the oxygen. The hydrogen then is blown away by the solar wind. That would, when it cools off, the rest of the water settles to the ground, freezes in the substrata. There's no geologic activity to return it to the surface. It's trapped subterraneanly and can't replenish the surface. So it was all tied to the geologic activity dying out. It's a direct consequence of how much basically uranium drives most of the heat generation in terrestrial planets. And if all the planets' compositions are essentially the same, they differ somewhat, but generally the percentage of uranium is roughly the same for most of our terrestrial planets and that uranium provides the heat source eventually making it to the surface. The less uranium you have, the lower amount of time you'll spend hot and resurfacing your stuff, the lower amount of time you have to keep a geologically active atmosphere. So as soon as that geologic activity stops, the volcano stops spewing out new compounds, it freezes out eventually or gets blasted away by the solar wind, and the atmosphere just continues. So that's and the Mars's period was relatively short to have that because it got this blast of influx, we believe, and that blast influx kept it powered for a while, but the leaky bucket was always draining it away, cooling it off, freezing the water back out to the surface, and ultraviolet radiation from the sun splitting the high energy, high atmospheric water components apart as well. Okay.
So the atmosphere it has today, is it pretty much at equilibrium in that process, or is it still losing and at some point lay up?
No, its atmosphere, it's stable at 7/1000ths, roughly speaking, because it's not got anything else coming out. All the stuff is frozen below the surface that it can have. And the solar wind has stripped away just about everything it can strip away. 7 parts per thousand of our own atmosphere is a really low number. And so, and of course, the solar wind is weaker out there, of course. It's almost, it's 80% further away. So inverse square law says you get about 2.5 times less solar wind at Mars than you have at the sun, than you do at Earth. So.
And just trying to put that atmosphere in perspective, that's less atmosphere than if you were standing on top of Mount Everest.
Oh, much less.
Much less, okay.
Yeah. You're a cut, all the blood would boil out of your body in 7.
I think you said it's a 30,000 foot aircraft flight.
Well, much lighter, much lighter.
We can't fly high enough, Grant.
Can't fly. Jim.
Yeah, you mentioned that the helicopter was proof of concept. Was Moxie, the Moxie unit also proof of concept?
Yeah, Moxie was basically said, hey, we're gonna need some way to get oxygen without having to scrounge up the subsurface water and melt it down and hydrolyze the hydrogen from the oxygen with electric current. We're going to have a more direct approach. So their goal, and again, NASA doesn't have it all worked out yet. That's why it's probably maybe 2050. It's better than idea than 20. But they say that we can't position. We're going to send the return vehicle there, right? And with a factory to create some oxygen for the propellant that will get it back, because it will not have, we won't be able to ship it there with enough propellant to launch it up and get it back here. So it's going to have to effectively do some of that stuff on the surface. So right now, the thing is that once we think we can make it there, shoot the big supplies, heavy, long 2-year path, low energy path with the really heavy stuff, make sure it lands safely before we would launch the guys back here. Because if their return vehicle can't get up, then there's no use sending them, right? Unless they want to die there.
There are people that would sign up for that.
There are people who would sign up for that.
They're crazy, but yeah.
To go back to the beginning where you talked about like 8 foot of rock in order to get nice radiation shielding, is that average or is that from extrapolation from the average, what they get day to day versus what they would see from CME coming in? Because a CME, it doesn't have a magnetic field check, but it's far away from the sun.
They can't predict, yeah, they can't make assumptions based upon unusual events like CMEs and things like that over the relatively short period of time they're going to be on Mars. What they said as a goal was the amount of radiation you would get as if you were like an airline pilot constantly living at the altitudes, not where they fly for the 8 hours a day or whatever they fly, but living at those ones. Those guys get relatively close to the lifetime limit of certain radiation doses. There you go. And so they set that, they kind of set that as a threshold that they can tolerate because they know they won't be there for a whole lifetime, right? Unless they die.
But a CME without a magnetic field, that's gonna really get hard.
Oh, yeah.
And they were worried about the accident. I think Alan Shepard himself said. he got it.
That's one of the things that we're very lucky, when they went to the moon, because if they had a CME, this kind of measure.
Oh, yeah, it's funny. It's all the things when you hear about it, it's like, well, what happens if this happens? Well, you'll die. Okay, what happens if this happens? Oh, well, you'll die. What happens if it? And it's
But
like,
how often will those things happen?
well, they happen.
But again, you go out, so now you get this little thing that's coming out, and this is the Earth, like, good distance. But as it expands and it gets to Mars, now all of a sudden it's like.
But the
Yeah,
flux
we're thinking-
decreases. The flux decreases because it's fragile.
So I would think there'd be a lot of ability to extrapolate out.
They're more concerned.
The distance.
They're more concerned with finding a way to have them live in a relatively long time. They, like I said, because of the 2-year launch window for the shortest path back, which is what they want to send people on, so they get the least amount of exposure. 6-month journey there, you're on the planet, 6-month journey back is your 2-year time frame to basically land it back in that position. Because of course, the window from Mars back starts at a different time than the window from Earth to Mars. So they're not a full 2 years. 2 months.
It's harder to slow down
Maybe
the
out position.
back there.
It's our launch windows that way are always 2 years and 2 months apart for the shortest path. But the way back, they're out of sync because, of course, they're launching to catch back up with us. So they're not at the same launch.
Great. Science is cool.
Yeah.
Is the bad radiation on the surface?
No, not
Extreme
X-ray.
ultraviolet? Extreme ultraviolet?
Um,
What is the
yeah.
radiation of the surface?
The-
You have to get 8 feet around.
Oh, it's mostly the SEPs, the solar energetic particles. So the sun puts out primarily the solar wind, which is just hydrogen nuclei,
So
helium.
you're talking about the you get shot of
And
protons.
those things interacting with other things create Bremsstrahlung radiations and things that put off gamma rays that can, the secondary effects that I talked about in some extent. And so basically, by direct of these high energy particles, and then the rays they create when they interact with other small portions of the atmosphere, they give off other dangerous radiations.
So Nebula has aside from the sun, you can look at the proton.
Yeah, exactly.
So I guess those protons and stuff are. it's not-
Yeah, oh yes, yeah, they bounce into each other, they hit magnetic fields, it's like any moving, everything that comes from the sun is so hot that the electrons have been stripped off of the nuclei, so the electrons are moving charged particles, they generate a magnetic field. The nuclei that are left behind, either hydrogen or helium, are also positive charged protons, so any moving charged particle is an electric field, that's how we make an electric field. That can, if you've got any other magnetic field, 99% of the time it deflects because you've got a tumbling spinning magnet hitting a permanent magnet, and it's almost always deflected. It has to land just right in order to come in. Mars has nothing, so that thing comes in like over and over, even though it's at a lower density because it's spread out further.
You get all those.
Right. Sorry.
On your thing about what happens, you die, what happens, you die. Well, it sounds like they're gonna die anyway, because it's not the single thing, it's a summation of all the little deadly things. You're not gonna stand a chance on it.
Well, and there's also physical effects too. It's like, how big of a thing can you actually send? And you're gonna encapsulate 4 people in a place much smaller than this room for, 6 months.
Yeah.
And then they're gonna live in a tent basically for a year.
They gotta go straight to lava.
Yeah,
Yeah, well, ideally, that would be.
what's his name would never have survived in reality. What's his name that got left on Mars, he would never survive.
Mark Watney?
Yeah.
And that's what makes it such a bigger challenge than the moon, because, hey, you can stop on the moon for a few hours and pop right back up because you don't have to worry about launch windows, landing windows, any of that stuff, not to this level, extent of level, right? You just don't have a choice. You can't, they don't plan to send enough fuel there to shoot people back at the most direct route, at route from any part in the combined orbits. You have to wait, right? You just have to wait.
I think Spiro had it.
Yeah, so. Well, what you're saying, I assume that in the space station, they get more protection than people on Mars.
Yes, and they have one particular room they go into during high solar events that has additional shielding. So they have, it's really just a thin sheet of aluminum mostly. It's not much thicker than that, but the aluminum shielding has got some padding and things with it that also blocks some of the radiations.
But the protection of the.
Yeah, exactly. We're within,
Yeah.
they're still within the Van Allen radiation. We're still lower than, they're still lower than, they're only 250 miles up, right? So they're within the Van Allen radiation belt, so they get all of our magnetic protection, and there's nothing like that on the way to the lunar Mars. Once you pass the Van Allen radiation belts, you're SOL signs up. And then your question back.
I have some. If Mars makes only enough oxygen, it's the same person for the planet cannot use oxygen it makes, right?
The planet can what?
The planet cannot use the oxygen it makes. Right?
The planet makes the oxygen?
So I think you said that unit made 12
grams.
But it's not the planet, it's the
It's the unit, it's our unit on the planet. It doesn't make any of its own mass. I mean, my unit.
So it was a science experiment. basically.
Right, it's a
Okay.
science, MOXIE is a science experiment that went along with it. And so basically it takes carbon dioxide, strips off, heats it up really hot. One of the oxygens kicks off, carbon monoxide is left, which I say is harmless.
Yeah,
And
breathe
then
it.
the oxygen cools on the other side of the ceramic plate, and these two oxygen radicals combine to form diatomic, or the oxygen O2 that we're used to breathing here on Earth. So they strip off one oxygen from each of the carbon dioxides, make carbon monoxide, and then two of those oxygens get together to hook up to make oxygen.
That's quite a process for a little reward.
That's a
Yeah.
lot of process for a little bit, and it's very energetically expensive.
Two things about that. The first one is, so when you say that the water gets broken down, the hydrogen gets blown off and the oxygen sinks, is that kind of?
When the water and when it makes it to the upper atmosphere, right? It doesn't make it up to the atmosphere anymore. I'm talking about the past, when Mars was dying. When Mars was dying, when it started to have the water in the atmosphere, and it was always getting separated to some extent, but that's why it lost a lot of the water it had, because some of it separated as oxygen, hydrogen components, hydrogen being blown away, oxygen doesn't have anything to combine with anymore. Makes a little oxygen, carbon dioxide, lots of carbon dioxide, things like that. And the rest of it settles down to the surface, freezes out, and is locked in the substrate.
So real quick, we've been kind of hogging it here in the thing.
Oh, sorry.
On Zoom, does anyone have questions for Stacy?
They've been off for a while, like 2 years.
No? Okay.
So
All
what you're saying then is, when we get up there, we're gonna have to do what those aliens did with our spaceship. First, they're gonna scale that oxygen unit
Yeah.
up on Olympus Mons.
Well, like I said, they plan on sending a factory-like piece of equipment there to start harvesting oxygen. And like I said, they don't have it all finalized yet. They know the numbers they need. They don't know how to meet that goal yet. You know, people have been pushing so much for Mars habitation that they're gonna try to make it happen, but
But if they were to
there's
do
a lot of
that,
unanswered questions and a lot of, if you ask them today how they plan to get enough oxygen for all their needs on the planet, they'll say, well, it's in process.
It's
We've
on
got
the
it.
list.
It's on the list.
but you
right?
know, if they were to do it inside of a lava tube and we're able to seal off the lava tubes, then it could, send a unit up there to, just generate it before
But then,
people got
of
there.
course, we have to find lava tubes close enough to the surface
Yeah.
and a place where we can land that's still safe to land.
Yeah,
and all
ship
that.
up enough RTGs.
So I'm walking around Mars in a spacesuit, wearing a diaper, breathing oxygen on my back, and I find out that Congress has cut my budget.
Yeah, but they had a funeral for you.
Well, then like.
If you're talking about the
On
Martian.
the, Left on Mars, movie, what was the name of it?
The Martian,
And then his name was,
Mark Watney.
so they'll set up the equivalent of Mark Watney, GoFundMe.
All right. Anything else for Stacy? All right, thanks, Stacy. Excellent job.
Did you do a poll that goes on to see if there are even people serious?
Yeah, they shook their head. You guys can hear. Someone speak up so Grant knows you're there.
I don't care.
We can hear.
There you go. Thanks, guys. All right, so we have 2 eclipses coming up. I mentioned this in the past, but we're actually getting to a point where, as a group, we need to make a decision if we want to do something with this. even though it's 2023 and 2024. So Don Ficken leads a Missouri Eclipse task force. And with that, they're able to get some of the glasses, which I have with me here. They can get them at a very reasonable price, but that price is going to go up sometime in October, you said, Don? And so I don't remember, I think it's like 35 cents a pair now, goes up to what?
This is 30 cents.
30 cents, and what did it go up to in October, like 50 or something?
No, I don't think it's quite that much. It's probably, it'll be some price, I'm not sure.
But it's only a partial eclipse here for both of them. And I know, like myself, I plan on going to a place where I can actually see them full on. You know, the Ring of Fire first and then the total eclipse. You got to go down to at least Farmington for the 2024 one. So as a group, what, if anything, do we want to do? I just want to spark some conversation.
Are they there?
Solar eclipse will always be the day. I don't remember the ring.
Well, it doesn't say solar up there.
The one in 2024 on April 8th, I believe it's like early in the morning, if I remember right. 1 o'clock. Oh, I'm totally wrong there. Okay, it's in the early afternoon. Don has got all this stuff. And what time is the 2023 one?
I don't exactly remember that.
Okay.
The 2024 is about the same time as the last one.
Okay. And the last one was in the afternoon.
See, about
It was pretty, I mean, it was pretty hot.
12 and 1 o'clock. probably.
Yeah. So it sounds like both are in the afternoon. Don. So,
I think April will be a little more pleasant to be out in the glasses around.
So it's hard. So it's hard for me to know exactly what the response will be, but I will say that at the air show, the booth is very popular. I happen to talk with Parkway Schools there, and they are all over this. They're looking to buy glasses, the whole business. So I don't know what that means. I do know that there's a lot of interest. I think one of the reasons there'll be a lot of interest is that it's probably going to be the last one. I mean, from a total,
yeah.
it'll be the last one we really get for a long time, and so there's going to be a lot of media interest about this, and it's just going to really going to hype it up a lot.
Yeah. And even if we don't want to do anything particular, like have an event with it, do we want to buy glasses at 30 cents a pop? And then just before these eclipses and a month leading up to them, that's when people are going to want glasses, sell them for $1 a pop or a couple of dollars a pop, which is what we did last time. And we made, you know, a little bit of money for the club.
Billions.
So
Let
what I,
me ask Jim a question. Jim, how much aggravation did you have doing it all?
It was a lot of work.
And so the question I would ask is, do you want to do more?
And I'll reflect on this a little bit. I don't want to.
Let's just say you can sucker somebody else into doing this the first time.
Well, you know, that is a good point that you can always assign this job to somebody.
And be a mentor,
Yeah.
So who's not here?
Or another boy. Okay, so basically back in 2017, we prepared several years in advance and we did a good job. And of course, it was coming right down our throats. You know, Winsville was in totality barely. We initially bought, I don't remember, 500 or so Eclipse glasses when they were super cheap a couple of years before, maybe, or a year and a half before. And then we bought more, and then we bought more, and then we bought a bunch more. The main purpose for the first purchase was for members, so that they and their families could have some.
Right.
And I don't know how many people in this room still have Eclipse glasses from 2017.
So, yeah.
We didn't have those before. But I know that even though a lot of people raised their hands already, if I ask for, okay, how many you think you're going to have new family members that either threw theirs away or new people are going to bug you for Eclipse glasses, those same hands are going to go up.
Yeah.
So I don't think it'll be nearly, 2023 won't even be close to what we had in 2017. 2024 could be more, but I tell you what, when I did Eclipse classes and we made good money off of those, we were lucky that a bunch of them, I guess Amazon or whatever, got some that weren't certified. And a lot of people had to send them back and they weren't in time to get, I mean, so I had locals all over St. Charles and St. Louis County, even down into Jefferson County, calling me up, wanting to buy several hundred at a time.
And Don, what's the minimum order? We could do 1,000?
3,000.
I'm sorry,
3,000.
3,000.
So I think, I guess I'm thinking that just a natural thing that will happen is that we as an ASEM will be doing outreach, going to, because they're going to know how the Eclipse works, right? And whether you're doing a library program or just for the libraries or schools or whatever else, they're going to call you. You probably want to get away some glasses during those. And so you say, well, how many of those would I do? How many glasses would that involve? I don't know. But 3,000 glasses the minimum. I think Slash has ordered 20,000.
That was one of my questions. So they've ordered 20,000.
They're ordered. They got board approval to do 20,000.
And so you're advocating doing some like sales trinkets where your giveaways.
Well, like just for example, we were out the air show. We gave away glasses to people. I don't know how many we gave away, but you're just going to do a lot of programs, and it's helpful to, if you do a school or something. Once that, we'd like to be able to give school glasses to explain how to use them properly. It's hard to say whether the schools. I think last time what was really interesting is that the schools, frankly, didn't know what to do. They didn't know whether to have class or be in school or be out of school. A lot of them, they were so freaked out that I remember Parkway literally made the kids keep the glasses on during the actual solar eclipse.
What a waste.
And so I think they're going to have, there's been no pushback problems anywhere that I know of, where there's going to, I think they're going to be rethinking that again. So this time, even though I don't think the kids will be in the total,
Right.
But I think for the two partials, I wouldn't be surprised if the schools will go outside or do something at the school as part of that. So the question is, you're going to be asked as a club, we'll be asked as a club to help them understand what to do, how to educationally do this. And so he probably needs something to work with. Otherwise, I mean, they may have glasses, they may choose to buy them.
I would expect that they will.
Yeah.
One of the schools at Hazelwood, they had a sack lunch and the kids had their glasses and they went outside and it was basically dismissed, called in here for lunch. And they went up there and sat up there, watched the eclipse.
And I think the other thing to think about too is that we always talk about eclipse glasses, but they're actually solar glasses. So they're good for education about the sun. And we did a lot of sun spotter stuff. We did a lot of projection, about how sunspot works, how we even put the sun spotter down and we showed how the earth moves and how the sun would move very quickly on that. We did a lot of education. So it doesn't have to be, it's not like when the eclipse is over, it's done. You've got something valuable to use. Yes.
It's been it would be 5 years. There's a tremendous turnover in registration school districts. Okay. The guys last time knew. The new guys, 5 years ago, they didn't do it. They're not going to know.
Yeah, but I think the difference is this time is that there's a lot of baseline now of what schools did and what they were worried about, what didn't really happen. So yeah, there'll be, I frankly think a lot of people, they might have classes, but a lot of them just said they dismissed the whole thing. Then they went by and go, I wish I would have done it. So I think there'll be a little bit of that going on. I don't think it's going to be as big as 2017 here, but I think you're still going to have some pressure from classes and education.
I think, yeah.
Chuck?
Yeah.
Yeah, Chuck. So I'm still working full time. I do have an audience and interest is still generating even with new people coming on board, and the engineering office that I'm working is about, seat about around 60, 75 people out of that. I'd say I seem to be seeing an average of around a dozen people given point in times interested in astronomy. The discussion of the eclipse has been coming up just since the beginning of this year, I noticed. And I have always left sunglasses on my cube wall. And of course, I got the calendar there. Thanks, Dan. So I get questions coming up and they said, are you going to have the sunglasses again? Because I don't care, even if I don't go to the center of the path, I want to see it from St. Louis. even though they understand it's a partial. So I'm beginning to hear interest in the sunglasses already on obviously on a small percentage basis, but it's beginning to be discussed, just for what it's worth.
Okay.
Okay.
Yeah, we need to make a decision next month since we have the picnic in September. I'm inclined to at least get 3,000, which at 30 cents a pop is 900, plus I'm sure there's taxes and shipping and stuff. At least, so we have some for ourselves and our families, and, as Don said, to give out promotional, talk about, part of our outreach. But let's talk about it more next month and we'll make some kind of decision on that. All right, great.
You get to make the decision.
Ultimately, I will, but I want to make sure I got the input of what we're going to
There's
do.
no board to approve it here. You are the board.
And Chuck, just to echo in on that, I mean, I took some chances on that before, and my findings were that what we got for the club initially, we went through pretty fast.
Yeah.
And so I got more, and then I got kind of cautious. I'm like, I don't want too many more. And then I thought, we're making pretty good money here. If we make a little bit of effort, we can put some in the bank. And I probably stretched it a little too far, but everything worked out great.
But it's going to be one of those things we buy now, and it's going to be over a year before we start seeing a return.
But the thing is,
Sure.
that it's the price. And,
Yeah.
and you got to store them, I realize, but I mean, if you can buy a certain quantity now at the low price and then have to buy another quantity at a little higher price, the average,
Yeah.
you still average in,
So a million, that only cost us $300,000.
So there's.
All right, time to move on. We're talking too big of money here.
So they're telling me that basically the paper prices are going up. And, one way to look at it is if you buy it for 30 cents, and let's say that you decide to sell some for a buck or whatever else.
Yeah.
You recover your money pretty quick. So you can actually take a chance and still not be down very much if you don't sell all of them.
And just on these, we would get the ASEM one, I would assume.
Oh, yeah, absolutely, yeah.
So
You can even design your own. You just have to have a camera ready to go. So.
Yeah, anybody wants one of these, feel free. Don donated them to us, but they do not have our emblem on it.
Let me throw this out too. How Dane's got that one really, I guess it's a singlet lens, but it's got like a really super long focal length. And you can project an image all the way across the yard, across the neighbor's yard, on the back, across the street. Surplus shed has those back in stock.
By the way, the one thing that we learned about schools is that they like the little toddlers that have cards, that they would actually put like a flat card, they would hold them up. And I also saw where they're using glasses, they would make a paper plate and then they would put that in there. But the cards are very popular because a little kid can hold that up and they don't have to worry about getting.
I remember they were doing that the last Eclipse with the paper plates. I do remember
And I
that.
think those are the same price.
Yeah, those cards are pretty cool. I guess they're more expensive than the glasses.
So moving on to our next one, I think I got these backwards. Don Lagwig and I were talking, and we wanted to kind of just go over real quick different ways that we can easily generate funds for ASEM. The Amazon Smile, I think we talked about this before. I do this whenever I order some from Amazon. I use Amazon Smile instead of just straight Amazon, and I have the donations go to ASEM. This does generate, small amounts of income for us that we use for our outreach and other things. So if you're not doing anything at all right now with Amazon, other than ordering from them, I would highly recommend doing this. It's just an easy way to do it. Mr. Twellman.
Just a footnote here that it's Alliance for Astronomy is the charitable.
Yes.
Yes.
That is correct. That's correct. So if we can send that out with an update on the newsletter, what that is. And the other one is company donations. Unfortunately, my company doesn't do that, but we do have, good ones that do. Jim Twellman is just a big one on that. So if your company does do donations, or you don't know if they do, at least ask. Look, the worst they can do is say, no, we don't do it. But if they do it, volunteer time that you put in, does make a difference for the organization.
What's been the revenue generated by that?
I'd have to look at that. I can get those numbers for the next meeting.
The smiling.
Yeah.
Is that generating? I mean, I know it
It- it-
generates
it-
something.
I think it generates a couple hundred at least, but I don't remember what, on like on a quarterly basis, what it is. But, well, Don could, but I mean, I'm thinking about, taking, we have a board meeting this coming Wednesday for Alliance for Astronomy. So I'll have everything put together. I can actually put a slide for that into the newsletter coming up. And then you guys will have all that information.
Yeah, if you've actually done that, there's a button on the small page. You click it, and it'll tell you what you contributed.
Yeah. And so when Don put this together, he put a whole thing about how to do the Amazon Smile. I'm not going to go through this. This will be in the newsletter. And also when we post this recording out, it'll be there.
That's a good point on the EIN there.
Yeah.
Chuck, why don't you just go back? That one does have, if you look right in the middle, about the Alliance for Astronomy in
There
there
we go.
noted.
Yep, that's what Grant was talking about too. Thanks, John. So, but yeah, that'll all be out so you guys can see it. So let's quickly go through the committees. Hospitality, thank you very much. Lisa provided the sloppy joes, and for those on Zoom, they were very good.
I need a volunteer to do next month's contract.
We need a volunteer for next month. Picnic is September, and I actually have a slide for that here. Yeah, so we need someone for next month. So I'm going to talk about the picnic, and then we'll come back and see if we got any volunteers. For the picnic, September 10th, we are at Shelter 3. So Jim, I don't know if you had actually set that up, but when I reached out to them, they said no one had reserved, and our normal was Shelter 4 was used. They said it wasn't us, but I'm wondering if it is. But anyway, we're going to be at Shelter 3 for that day. I am going to actually grill. I actually like grilling.
Depends on how hot it is.
Well, I'm hoping in September it won't be bad.
There's
So
been days.
I am honestly thinking pork steaks, hamburgers, and brats. Does anyone have issues with that?
No.
All right. Should I pick up soda? Pick up soda to bring.
I personally believe that if you provide the meat, everybody else can bring the nutrients.
Everybody else?
Just like a regular lunch meeting.
Bring your own beverage.
All right. All right. So this will be out there too. So it's got a nice little map where it is, but I think everyone's been there enough. Hopefully we'll get a lot of people. I'm honestly thinking about just sending a general thing out through the STL astronomy group and see if we can get some interest from some of the / people or just people that aren't members. I would love to see some more people out there. Maybe we have some potential new members, but I mean, it's the astronomy group.
So not just club members opening it up.
I'm leaning towards that. Yeah.
Okay. It depends on how much.
Friends and family.
I'm
Put a sign up as people driving to the park. Come get a free.
going to pick up a lot of Rod's burgers and pork steaks. I think we'll be good.
We'll probably be.
I hope so.
I think so.
All right, so I'm done with the picnic. Any volunteers for bringing dinner next month?
Andy, I would ask a special favor of you.
Yes,
Would you bring the ice for next meeting?
yes.
Because you can only get big ones, and I save and reuse ice for subsequent meetings, and my freezer is full.
I'll bring, like I did.
That would be
Andy thought he was
great.
getting volunteered.
Okay, so that lets you off the hook for cooking,
Okay.
unless you want, but nonetheless, I need a volunteer.
Yeah, I'll do that. I'll be the ice person.
All right.
Okay, thank you.
I'll be in Minnesota.
What a lame attitude. All right, I am gonna come back to this.
This is just August. This
Let's
is-
keep going. So on loaner equipment, Carl is actually out of town on a fishing trip with his brothers. Not a lot of movement. I believe Tian's got the 18-inch. He is absolutely obsessed with it, but it's an obsession. So he sent a bunch of text messages on it as soon as he got it. I think a number of us got it.
Just regular.
So,
3/4 ton.
but anyway, any movement of equipment, reach out to Carl. It's at the equipment.asem.org one. So, library telescopes. Last event was just last week, or was that this week? This week. That was Thursday night at the Middledorf Kriegel branch. Amy White, Ken, and Fred all there helped out. We had 23 people, a lot of little kids. We went outside hoping to see the moon, and every now and then it would kind of give us a glimpse, but not long enough for us to actually get it in the scope. But everyone just had a great time, so it was really good. Our next one is August 1st at Catherine Linneman. So any help with that, I would appreciate it. We've only got 3 more coming up, and then we're done for the year. So come on out and help. There is awards for that, as we talked about earlier. So you need 20 hours to get the first one. And it's not just volunteering here, volunteering to help, any kind of other things with the telescopes, any kind of maintenance and stuff does count towards that award. The next event for the larger thing, the National Library Telescopes things, is going to be Wednesday, July 20th. That's a week from this coming Wednesday. I will be doing a presentation on 3D printing. So I'm going to talk in general about 3D printing if you want to get into it, and in particular about for the library telescopes and things that we've done and things that people can use. So join in for that. That may be a presentation I give in the future in one of our meetings too, but that should be fun. That should be fun. Any questions on that? Beginner, Jim is out of town. He is in KC this weekend. I did the beginners meeting today. We did not have anyone here. I can't speak for the last few though. Programs, always looking for programs. I've been kind of reaching out to people at different times about different things we can do. If you've got something you'd like to do, whether it's 15 minutes or 30 minutes or 45 minutes, let me know. I just want to make sure we have good content and we fill our content for each month. Yeah, Grant.
You got next month, August?
Do you want to do next month? Okay. Yep. Fun things with the moon. All right.
There may need to be an update with James Webb next month too.
All right.
I can take it, throw it in there too.
All right.
He's
DYI.
I'll be out of state.
Oh, that's right.
Tom, I know you're on.
Right.
What's
I haven't
the-
heard anything from Steve, and I'm still in the same boat. I can't even get home till about 6 o'clock, and then I'm dinner and I'm done at 8. So here at the house, so I'm still not able to participate, but I was curious what, if anything, Carl had going on with it, but I haven't heard nothing. I'm sorry.
Yeah, I don't think anything's been going on. And I was going to ask the question, right now we have reservations here at the Interpretive Center for the DYI and also for the digital SIG. I'm thinking about just canceling those for now.
Yeah,
And
I
then when
agree.
it comes back up, then, we'll do them again. But I'm getting calls about them from the Interpretive Center and I don't always know the answer. So I think that might be the easiest way.
So check, do it yourself is also kind of encompassing Jim Rose Telescope Building.
Yeah.
Yeah,
Yeah, and I'm hoping he was going to give an update on this. I was hoping he was going to be online to talk about it, but we'll get an update on that for next month.
okay.
All right, so Dan on digital SIG, thank you.
Just the same thing as we talked about last month. We're gonna have a couple people talk about the recent astro imaging conference that was in California. Greg Ripple's going to talk us about some of the presentations he went to. And then I have a guy by the name of Dale Chamberlain, who's from Brighton. He's going to talk about some of the other presentations that he went to as well. And then that group is out there has done really nice things recently. They've offered up all of the presentations for free. So we're going to give out a link so you can view them. They very professionally done and the best of the best people in the world. So we'll provide a link to that as well.
Okay.
And I have a feeling we'll see some of those presentations in our meetings over the next year or so too. So that's what we had the third Tuesday of the month.
Okay, thanks, Dan. All right, and then the last one we have is observing programs. And Steve, I was wondering, should we push this one off to next month, or do you need to talk
This will
about it?
take 3 minutes.
Oh, go for it, my friend.
Fifth, Spring Galaxy Challenge is open for collecting. If you still have a chance to put it in and type it up. So far, I know Andy did it, got it paper. David Wood got an email. Dan got it. Dan did it, got it. Anybody else? Does anybody? Okay. If David, I got a certificate for David, and I don't have one for him, but we can give it to him some meeting when they're there. And the rest of it's there, and no big deal. Boom. If you're wondering, that's what the certificate looks like. Boom. There's a globular cluster challenge. It just started. It started on July 1st. You're supposed to image 12 out of 38. You're supposed to either draw it or image them. You've got to do an outreach activity, and it runs till October. And there's a web page.
And that's the one you referred to in your earlier talk.
Yeah. Boom. Wait, and I'll give you boom.
Look
If
at
you
that.
wonder what your certificate looks like, it looks like that. I was the first person to do it. Boom.
Is there a pin?
No. Really? Dan talked about this before, James Webb. I don't have to say anything about it. It'll be in the newsletter. It'll be over by then. Beep. And then Alcon, if you want to go to Alcon, it's in Albuquerque. They're still accepting reservations. Beep.
Look
I'm
at
done.
that.
Good job.
Didn't I say 3 minutes or less?
Outreach, you did outreach. Two outreach events.
How did I miss outreach?
I don't know. 2 outreach events, 2 weeks from tonight. One at Bromelseek, Girl Scouts. I'm spearheading it. Need one more volunteer. It's in concert with the James Webb. It starts early, 6:30. Officially ends at 8. Of course, there will be people there to stargaze afterwards. What they need is one person to run an activity they have planned, and all you got to do is take the group of girls that comes over and run them through it. You don't have to do the activity yourself. You don't have to prepare the activity yourself. You just need to be able to guide the girls through the activity. And then I will stick around if there's anybody left to stargaze after that. Girl Scout rules say you can only be so long without a bunch of different things, so it has to run from 6:30 to 8. Officially end at 8, but I'll be there to run the telescope if you event that. The same night, Moth Night, down the road here at Bush Wildlife at the what site is it called? Just have it on my phone. Yeah, but it's I had it here for all the details. Basically, it starts at 8:30, and they want us for stargazing, and they will have a backdrop. They will dim some of the lights around the area. They'll let us choose our location, and then it's bigger. So on the bait shop side, if you've ever been to the Bush Wildlife area, there's a bait shop next to the center there, and greeting people in front of the bait shop, informing them what's happening. There will be live musical performances in the area. Directly behind the bait shop, the Dark Sky Association will have an informational table in the breezeway, turning off the parking lot lights to allow some darkness, and have luminaries to guide them to a place where they'll have a sheet set up with a black light to show flying insects at night. And so this is in honor of Moth Night. Apparently it's a big thing. I haven't seen it. And then they will be starting as early as 3, but we only need to be there set up at 8, show, and they'll announce the stargazing starts at 8:30. So ideally, there'd be 2 people and 1 to lead. If you're interested, give me a holler. I'd appreciate it.
All right. And for whatever reason, don't have outreach on here. Need to add that.
Yeah, I know.
The print does look bigger.
So.
You
All
can get a
right.
separate slide.
All right, that is it, folks.
Hey. Good job.
Yeah, we still need a volunteer. I'm going to,
But Andrew volunteered.
No, I think.
Ice.
Ice.
Oh.
I'm nice,
The
man.
ice man come.
all right, thanks everyone on Zoom.
Good job, Chuck.
Good job, John.
Hey, they have to wait for the volunteer too, don't they?